My name is Dan Amiga. I'm the CTO and co-founder of Fireglass. Dor, who's going to run the presentation with me, is our security research team leader. And we're going to talk to you today about a subject that we feel very passionate about, which is really, what do you do whenever a user tries to download a document into his machine? What does the IT or what does the security staff or how does your security poster should look like whenever someone tries to download a potentially malicious document? This is a result of a work that we've been doing with customers around the world, really, US, UK, and now in Singapore, where I don't know how much of you guys know, but have you heard about the fact that the government has decided to spin up 2 machines for every government employee, just for full isolation between internet environment and internal environment? So what happens is, what we've done in Fireglass is we've built this isolation component to make this happen for financials, etc. And along the way, we found a very interesting problem, which is, what do you really need to do whenever a user wants to download a document? Do you sandbox it? Do you run it through static code analysis? Do you run it in how do you detect a true type, etc.? And what we found is really interesting behaviors, and we'd like to share kind of like the way, as part of this applied security track, kind of like the way that IT professionals, security professionals, and also the Black Hat community should look at this. And we call this the relevance of K-bytes detection, because we also found quite a few interesting ways of how to evade things like true type detection, etc. The end result is to really explain what's the right workflow and pipeline to orchestrate the scanning and verification of a file, and let users download a Word document, to be very simple. So what I want to do today is really, I want to talk a little bit about the problem space. How do files get into the organization? It's 2017. It's pretty legit to tell users they're going to be fired if they stick in a USB key. So that's fine, but there's so many other ways for files to get transparently or not, driven by user action or not, into the organization. So we'll talk about that. We'll talk about what is a document analysis pipeline, and how do you actually chain vendors side by side, and why should you chain vendors, and kind of like the differences between best of breed versus a single vendor. And we'll also talk about the evaluation criteria when you talk about document analysis. What's more important for you? Business, cost, security? It's never security, by the way, right? It's always about the business first, the costs first, then we talk about security. Then we'll actually dive into the relevant components as part of the document analysis pipeline, all the way from sandboxing, content disarming and reconstruction, static code analysis, isolation as well. And we'll actually show you a few alternatives and workflows. So to start with the actual problem space, this is a screenshot. Well, what's important is actually the white text, not the attributes themselves. This is an XML file it's part of a true type detection engine that's being used by things like VirusTotal, etc. What you guys should really look at is, I'll explain what it says in pink or in red where you guys can see, but what's interesting is actually the white text. This is a schema that actually verifies if a Word document is indeed a Word document. This is part of a document true type detection engine that was written by an Italian guy called Marco, which we have references with in the end of the presentation. A very popular tool called TriedScan. And what they've done is they basically have a few thousands of different file formats or file signatures that you guys can use, and they also have a training tool which you can feed in documents of a specific format and build the schema file for that format to really analyze and decide if a document is a valid document, is of a valid format or not. So in this example, what you'll see is that the verifier actually looks for a PK ASCII extension, ASCII prefix in position 0 of the file, and then once that was verified, and it makes sense because all docx, xlxx, the new Office file formats are indeed zip files, right? So they're actually looking for the validity of the zip file, and then after they verified it's a zip file, they're going to look at some global strings, and they're going to look at these document XML relations, content types, relations words. So they're actually going to match those strings. Once this check passes, there's a high accuracy that this is indeed a docx file. The problem is that actually the underlying applications, specifically OpenOffice, or if you do Office for Mac, or even the new Office versions on Windows, would actually try to attempt to open the file with a docx extension, even if you remove those global strings. So it's just one example, which we'll come back to later, on how these TrueType detection mechanisms are not enough to verify if a file is really what it says it is. Until you open it and verify, you don't know. But the problem is when you open the file, it actually executes, right? So we'll come back and talk about that. TriedScan is a very interesting tool. If you guys are not aware of it, I really encourage you to go online and check some file formats and some file signatures, and you can also download the database. So given that, right, we'd like to take a look at what are the popular file formats, and this is actually a 2014 chart. There's been a lot of other file formats that has been introduced into this, and the statistics tend to change, right, based on a certain vulnerability. But as you guys can see, doc and docx are still, after RTF, which is a very exploitable file format. So this 22% column, right, this 22% column, which represents Office files in general, being Word being the most popular one, is one of the most popular file formats as attack attempts. And one of the problems is that from IT security perspective, we think that macros are the only thing that could be bad in a Word file, but that's not true. It's not enough to just remove macros. And we'll come back and talk about this, but it's just a view of the different file formats. Notice that executables and PDFs and JPEGs were pretty down in terms of statistics. That's because, first, for executables, a lot of organizations block executables in the first place. But we're going to focus more on concrete file type examples. So this thing tends to vary, right? If you look 10 years ago, you would see TIFF format, right up there. We had recent attacks in the past year with JS files. Once you can send those with Gmail. But it's just interesting. It's just interesting to look at these popular file formats, and we'll come back to the attack vectors. The next thing we want to understand is how do actually files get in, right? And and it turns out this is actually a very interesting concept. So if you look at a given organization, right, a lot of organizations today employ some sort of user education, phishing education or training in some sort, but yet the click rates are just enormous. So do you guys have any idea of what is the average click rate after a phishing campaign education with financials in the US? Say again? It's not 60%, but they don't publish the actual numbers. I can give you my own average, right? So my own average, asking, I would say, the top 20 financials in the US would be around 18% click rate, right? Now, these guys are pretty big shops, right? Anywhere between tens of thousands to hundreds of thousands, right? So what you get is 100, on an average, let's say 50,000 employees time 15% or 20% or even 10% click rate for a phishing attack. That's pretty intense. So despite user education, how do files actually get in? So there's the trivial examples where users just go on and click stuff, right? So if you download a file from a valid website, that might be okay. The question is, how do you verify if a website is valid or not? We'll come back and touch about the differences between URL categories and URL risk levels in a sec. The other way for files to get in would be email. And then what we see is that even though companies really employ protection mechanisms, right, like DMARC, or specifically the DKIM for authenticity or sender policy framework, that still doesn't say anything about the data, and it doesn't actually say anything about the attachments inside. And in fact, when you actually talk to these companies, I just got back from a conversation with one of the biggest banks in Singapore before I changed clothes to sneakers and stuff. And what they told me is they were around the 15% click rate, right? But then what they did is they sent an email from the CEO. It looks like their domain, right? They did the whole DKIM and SPF for a domain that looks pretty similar to what these guys are doing. The click rates were around 80%, right, including security and engineering. So although the domain employs DKIM and sender policy framework, right, it doesn't say anything about the content. And a lot of the ways bad stuff gets in would be via email, not a surprising thing to you. The other thing which would be interesting and tend to be overlooked would be the other vectors, right? So you come in and you ask an organization, what are your attack vectors, right? So if they're not talking about insider threats, what they're going to talk to you about is about web and email, right? But what about these guys? What about chat applications like Slack or Web WhatsApp or any of these guys, right? They tend to be overlooked. In fact, if you look at some of the proxies or some of the next generation firewalls, they don't even have visibility for a period, or they didn't have visibility for a period of time on some of the new chat applications, right? So that's another way how you can get files being sent over. Not to mention the recent Cisco vulnerability, right, where they can trigger, the extension would trigger a file download. And the other interesting thing, one of my personal favorites would be file sharing. So what happens is if I have Google Drive or any other sync application, if somebody on the other side of the world will place a document over there, right, that gets synchronized to my machine without any action whatsoever. It seems legit, it's already there. So there's all kinds of ways, non-USB wise, right, that gets files into the endpoints. The last problem is actually interesting. What happens if the file is password protected? So how do you get visibility if the file either compressed or archived, or if the Office document itself is compressed? You take an Office document, you apply password protection on it. Even if it's an XML format, even if it's the new Microsoft formats, right, that becomes an OLE object, right? What do you do with that? Do you block it or do you allow it? If you block it, the problem is most targeted companies in the world, if I'm a healthcare company or a financial company or not, my vendors, my partners, they really want to send encrypted documents to me. Right? So it's always a question of what do you do with this guy, and we'll actually come back and talk about that. The web is especially interesting. I call this the web browsing security problem. And the way it looks like is if you take any given proxy or any given next generation firewall that's supposed to actually apply some security policy on the files, right, or at least on the URL where these files come from, what you get is you get this list of risk levels. And this is logical risk levels. Any vendor has different risk levels. And what's interesting is any URL in the internet, once you make a request, goes into one of these risk levels. Now, the problem is that it's extremely easy to actually say if something is known good or known bad, right? It's pretty easy if you look at the CNNs of the world, even the Forbes.com, which had the famous water holding attack, minus the advertisements, right? It's a pretty valid website. You can actually get good tracking and good reputation for it. So you can actually let your users go there. But, and then on top of that, it's also extremely easy to know websites that are known to be bad. So I always like to say if my grandma on the other side of the world would click a malicious document or a malicious URL that would trigger a drive-by download or a phishing attack, Google, if she uses Chrome, Google, and she does, Google would actually detect that. And once they detect that, or if they detect that, they're going to propagate that URL to all of the endpoints, right? So if you guys don't know that, it's a very interesting fact to read about how Google balances between the fact that the URL database of known bads is so big, right, and the fact that they don't want to make a request all the way to the threat feed databases on every request or every DNS resolving you use. So what they do is they push what's called a Bloom filter. So you guys have on your machines a Bloom filter with known bads URLs, not that big. So known bad is actually pretty easy to do as well, right? And you know, we get this today free from our browser vendor. The problem is everything in between. Everything that is newly created domains, uncategorized traffic, any website in the cloud that I spin up falls into 3 to 7. So if you go to AWS or Azure or Google App Engine, we spin up a website, nobody knows what it is. If I go in onto a content editing platform and I write a new blog and it has a new URL, a new DNS entry, nobody knows what it is. So the problem is really when an employee or when a user goes to these websites, you can't really block them from one hand, because if you block them, you just block every new startup, every new restaurant, every new blog post, right? Possibly every new URL under S3, right, in AWS. There's really nothing you can do to block it. If you did block it, you would solve a lot of your security problems, but you would have to hire a huge help desk to open those. And on the other way, it's extremely hard to actually allow them, because this is where the majority of the bad stuff gets downloaded. So it's just interesting to understand where stuff gets in. It really gets in from categories 3 to 7. In fact, once a URL becomes unknown or uncategorized and none of the thread feeds in the world have seen it, which is a very low-hanging fruit when you start a hacking campaign, right, or when you start a malicious activity, you would either use a domain that you bought 2 years ago, right, or you would use a newly created URL, right? And that's going to fall into an uncategorized or unknown in the vendor's database. And this is just from one of the biggest vendors, right? Be aware that setting the action to block on an uncategorized URL, we like to call this uncat, may be very disruptive to users because there could be a lot of valid websites that are not in the URL database yet, right? So you can't really block it and you can't really allow it. And then same goes for the mail authenticity. If you guys have SPF or you guys have DKIM, we talked about the example. It only verifies that you can actually it only verifies that no one alters the message, right? But if that message is specially crafted from a well-organized domain, it doesn't say anything about the content of the message. By the way, the big difference between mail and web is that in terms of productivity versus security, Email is fine to hold on for another 20 seconds or 30 seconds or a minute, right? If I would ask you guys how many of you use the undo functionality in Gmail, a lot of you are using the undo functionality. You don't care that your email will be stalled for another 20 seconds, right? 20 seconds in the web, it feels like 20 days, right? So you can't really do that. So there's also a fine balance between holding users from accessing web content versus email content. Not to mention file synchronization. File synchronization is just transparent, right? It's all the way behind the scenes. So the question is, what are the tools that we have to actually apply on whenever we want to get those bytes, right, downloaded to our computer? Which is also very interesting before we jump into the components. Another big difference between mail and web. So if mail is very transactional, so my MTA would get the entire email to be processed, right? I have the file in hand. While a web firewall or a firewall or a proxy, right, has to start sending bits back to the endpoint. Otherwise, the browser would time out the connection. So if it's a big file, you have to start using things like trickling, right? And then the first 10 Ks, the first 100 Ks are already in the endpoint if the file is malicious, right? It means that the first page on the PDF is already on the endpoint by the time the sandbox has finished scanning. So what we figured out is that there's all kinds of different components, right, and different vendors, different open source projects, and we came up with this concept which we call the document analysis pipeline. And we'll talk a little bit about executables, but in general, the document analysis pipeline is composed out of several completely different components, different in terms of cost, time, productivity, security, accuracy, etc. And what we want to do is we want to walk through these and actually understand what makes sense and what doesn't make sense, and in what order. The purpose is to take the good things from all of these guys and to try to eliminate the bad things. So if a sandbox takes a lot of time, for example, can you do things while the sandbox is working, right? We'll talk about that. And then the other thing is, as a backup, one broken link. So if one of these guys fail, we don't want to have the file actually enters the perimeter, right, or the endpoint. So a combination actually works quite well. An example for one broken link, there's a lot of vendors today that are actually offering an aggregation of anti-malware or antivirus solutions, right? But again, if this is new signature, nobody knows exactly what it is, right? So it doesn't matter if you have 50 or 60 antivirus engines. It does matter if it's a well-known file, right? So if it fails on those 50 or 60 aggregations of antiviruses, maybe the static analysis or maybe the isolation or the CDR component is going to help. To really understand, and we're going to touch on those boxes in the next slide, but before we do, to really understand what are the evaluation criteria or vectors when you look at a component like that. It's really about, there's another vector which is cost, but it's really about how secure, how much security do we get. So the best example would be what the government here in Singapore did, right? Let's just do hardware isolation, right? Let's just put one computer here and one computer there, right? What we did is we actually damaged productivity a lot, right? Because I can't actually move stuff from one place to the other, but I got a lot of security, right? So the three main or popular vectors would be, what's the security level? How much time does it take us to actually understand if the file is good or bad, right? And then how much do we damage productivity? The example with productivity would be if we would take every Word document or every Excel spreadsheet, and we would convert it into a PDF and then take every page and convert it into a bitmap and to a JPEG, and we'll give back the user just a series of JPEGs or bitmaps, right? A bitmap is an RGB matrix after we converted a few formats would be great in terms of security, really bad in terms of productivity, right? So those are the evaluation vectors. The first component that we want to talk about, that's important to talk about, will be the file type detection, what I started the presentation with. So file type detection, it's probably a very fast component. So all you have to do is you have to match a file with a few signatures, and that could be 6,000 or 7,000 signatures, or you can just limit the whitelisted file formats. And when you do file type detection, what's interesting, it's really a function where you pass in a memory stream, right, and you get back the relevant MIME type, right? So the obvious way is to start with a match on extensions. Once you know the designated extension, right, which is not a test, right, you then go ahead and start looking at either magic bytes, right, so either magic order bytes or character distribution. So magic order or magic numbers is something that's well known. We've seen it in the beginning. Character distribution is a little bit more interesting. What do you do if you get an HTML page and that HTML page doesn't have an HTML tag and doesn't have a body tag? The browser can still evaluate it as a valid HTML page and execute the JavaScript inside, right? So what you do is you look for character distribution, right? You look for greater than, lower than tags, right? To figure out if this is actually a valid HTML file or not, and then once you have enough valid character distributions, you start to look at the actual HTML tags. We'll talk about the Telegram and WhatsApp latest hack in a minute. Those are going to cover that. The problem with file type detections is not only you can get around it, if the underlying application tends to be more forgiving than your file type detection, right? So if you actually remove the correct signatures and the file type and yet overcome the file type detection, the problem is, and this is interesting. This is part of the API to actually use the file type detection library. And what's interesting is the analyze results. So actually, analyze results will get us this data structure that says T results, and will actually tell us what's the file type, what's the MIME type, but then on top of everything, we only get a percentage of accuracy. So if you match one of the file types, any of the file types that we actually showed in the beginning of the presentation, primarily Office file types or PDFs with different versions, you'll actually get different levels of accuracy, and then you have to decide on the threshold. And that becomes a problem. So even the best file type detection mechanisms can't make a decision on whether a file is really what it's supposed to be. With that, I'll have Dor talk about a little bit about the latest WhatsApp and Telegram, and then targeted email attacks.
Thanks. Before we dive into other components, I would like to talk about two examples to really understand what is the problems with file type detection for human beings and for software. So there's a very well-known attack operated by PwnStorm. This is a group of hackers that, in my opinion, is backed by government. They first seen as in 2004, and they operate until today. And I want to give you one example of the simple things that they do in order to manipulate users. One thing they do is they use the right to left character. They send you a zip file that contains two files, one which is a doc file, which is pretty legitimate doc file, just to make the other file look like suspicious, which is the PPT file. And they use the right to left tag in order to reverse the way it looks. So it's not a PPT extension, it's SCR extension, and you can see that the type is a screensaver, although it looks like the extension is a PPT file. This is really, really good into manipulating human beings, but not softwares. And when they actually execute the what looks like a PPT file, it drops a PowerPoint and it looks legitimate. And Telegram's and WhatsApp case that recently been discovered by Checkpoint security researchers, they used the fact that WhatsApp and Telegram had to implement end-to-end encryption. And when you implement end-to-end encryption, you have to rely on client-side verification. Since you cannot read the file at the server side, you have to do this client-side detection of the file at the client side. And it is a problem because they cannot know which file they send to the which files they send to the other client on the other side. It is really easy to bypass the client-side verification. So in Telegram's case, for instance, what those researchers did is they take a pretty legitimate MP4 file and they concatenate afterwards an HTML file. If you will run a file type detection on this file, you will probably understand that this is an HTML file. But when you're trying to open it inside an HTML5 video tag, it will execute the video without any problem, and the video will display correctly. But when you open it in a new tab, the context completely changes. And now it executes the HTML file. So it depends on the context you're running the file. It can be an MP4 file and it can be an HTML file. And everything changes in the context and not the exact file type detection. Another component is signatures components. Those are good to recognize known threats, but really easy to manipulate. The only thing you need to do is to change the file a little bit or look for the things that change the file, that change the thing that they sign on in the file to make it look different. And if you gain the antivirus and you can test it in your environment and look for how to bypass the signature. Another great component is static analysis. This is good for this is used heuristics. One good heuristics is that code does not need to appear inside the PDF or doc files. So when you open a document file, you're not supposed to see code inside it. And one good heuristic is to look for opcodes or executable inside documents. And if you see one of these, just don't let the file get inside your organization. Another great thing you can do is to parse the file and connect the components as they should be inside the file. And if you see a component that is outside of the file structure, it's probably a malicious component. If you follow the structure and you see an executable outside of the structure, it's not supposed to be there, and it didn't make it the way it's supposed to be. The bad thing with static analysis, this is really good to find binaries, but is really bad when it comes to macros or textual formats. It's really hard with static analysis to understand that JavaScript is malicious or macro is malicious. The component I like the most is Sandbox, because it sounds really, really effective, but apparently there are many ways to manipulate Sandbox. They use Sandbox to inspect web HTMLs or files, and when you execute the page or the file, you look for indicators if the file is good or bad, or if the web page is a phishing web page or it contains an exploit, for instance. The problem with those sandboxes is that they rely on known indicators. And when they take the file, they spin up a computer that's supposed to be the same as the endpoint's computer, the same operation system, the same browser, for instance, but they can't create the same context as the client. For instance, if you create a file that before we execute the exploit, it checks if it runs on a VM or an actual PC, and if it runs on a VM, it does not execute the exploit. you can easily bypass some of the sandboxes. You can create a delay loop to execute the file in 5 days from now. There's one good example I like the most, and I want to demo it for you. This is a web page that I created earlier today that seems legit, but when you open it in a different context, the website changes completely. So let's take Google Safe Browsing, for instance. They execute the web page and they try to decide if this website is a phishing website or not, or if it contains an exploit or not. But if you open this website inside Google Translate, internet problem. Okay, so when you translate the page using Google Translate, it looks like Google phishing website. So it changes with the context of the execution. So how it works? Inside this web page, there is a div containing this string. Hola mundo. And when you translate it, it changes to hello world. And we basically have a code here. We basically have a code here that when that looks for this string and is there. One moment. The payload here is encrypted in the file, and it looks for the key, hola mundo, and it tries to decrypt it with this string, which is encrypted with the string hello world. So when you use Google Translate, for instance, to see this page, the string hola mundo changes to hello world, and it successfully decrypts this content, and it changes to the phishing website. Done.
By the way, a few more comments on the sandbox pieces. Over the years, vendors have tried to create yet another better sandbox. A few of the major issues were performance, right? So if I have an organization with, tens of thousands of files being downloaded a day, how do I actually scale this? And then becomes always the dilemma, do I do this on-prem because I don't want to really send my files to the cloud, even if it's a dedicated cloud. So scale and data locality, right? I don't mind sending a signature, but sending the actual document would be a problem. Were two issues, and then some vendors try to implement some variations of VMs and try to utilize instruction sets for virtualization technology, etc. The other interesting thing with sandboxing is that a lot of the new malware actually tries to probe and detect if it runs inside a sandbox. So some vendors actually deployed mechanisms to detect whenever an executable or whenever a document tries to detect if it runs inside a sandbox, right? So it's always a question of where are you in the curve and how sophisticated, right, the vulnerability and the malware is. The next, we have two more components to go, and then we'll talk about how we orchestrate that. The next component would be what's being called in the industry today a CDR, or data sanitization. CDR stands for content disarming and reconstruction. And what it does is, it basically means we're going to alter the internal file structure. So we're going to maybe change formats, remove embedded objects, maybe convert the file format altogether. The best example is what I talked about, where you take a document and convert it into a series of images, right? But then you lose a lot of the functionality. So that's a good example for CDRs. What happens here is we've got this malicious *x document, docx in this example. It has macros, it has opcodes, it has executable content, all kinds of malicious content, fonts, right, layout and text. And what we can do is we can actually convert the document into an intermediate file format. An example would be OpenOffice or an HTML, or we can jump a few formats, right, and then end again with just the layout and the text in the docx file, right? So obviously macros go away after you save a document as HTML and then reconstruct it back to a docx file. That's pretty fast. It's not a slow process. It's also pretty good in terms of security. The main issues would be around fidelity, right? So first of all, maybe we do need to use macros. So it's all about policy in the organization, right? And then second of all, at the end of the day, once you start to actually jump between one format to the other, which is absolutely a great way to clean bad stuff, you end up with fidelity issues. How do you reconstruct the document to its original form in terms of capabilities, let alone talking about Excel files, the formulas, the pivot tables, etc. There's other types of CDRs. The CDRs that actually will check the validity and the schema of the document, so make sure nothing actually sits outside of the schema. And then there's some schema manipulation. But again, all of these guys have some fidelity issues. We've also seen some attacks, especially by the red teams inside the organization. So it's just a matter of time until this stuff gets out, where they actually find workarounds, right, such as dynamic imaging. So what happens if I place in a dynamic object that my Word document pulls down from the internet every time I open it? I can actually change the target, right, after the CDR, after the document is already on my endpoint. Fonts were always an issue when there were font vulnerabilities. But absolutely another important piece where at the end of the day we take a document and we convert it, and by converting it we actually disarm and then reconstruct it back to its original form. The last component would actually be taking an action of the file in terms of actually remotely visualizing the file. So what if I get a Word document and the first thing I do is I then open the document in a remote desktop somewhere in the cloud, right? What that gives me is, well, I don't have the document on my endpoint, so I do have productivity issues for the time being, but as an end user, what I can do is I can actually work on the document, I can look at it, I can verify the authenticity of it. I can even run some security solutions in the cloud, so even if the user enables macros, then if the bad code kicks in, we can detect that, right? The other thing you can do is, this is a really good intermediate step, which we'll talk about in the upcoming slides. What happens if a sandbox takes 20 seconds or 60 seconds, or if you need user interaction through the sandbox, what you can do is you can view the document remotely, right, and then send those user gestures to the sandbox, or just scan the sandbox in the background. This is great. There are a few issues with this thing. First would be, how well is the actual display environment? How much functionality do I get? What's the scale factor? Again, if I have 10,000 files downloaded a day, do I spin up 10,000 remote desktop environments? What about latency? How long does it take me to actually spin up a remote desktop environment when I download a file? And there's been some vendors that actually are solving the scalability issue and the performance issue. So what we did is we talked about the relevant components. Now let's see how we actually put these guys together. What's the right way to orchestrate these things? So the first thing to understand is when we talk about a pipeline, before trying to actually decide what do we do with the file, there's all kinds of decision criteria or metrics that we can apply, right? So for instance, different source senders or source IPs, different destination URLs or destination senders, right? Different users can deserve different workflows or different order of components. Other vectors would be geolocation stuff, would be compliance in the organization, etc. So a good example for that would be if I work in a call center, right, and I'm a student, and I have access to all of this, crown jewels of the organization. I've got access to your social security. I've got access to all of the call center data. Every document I try to download could be isolated completely. There's no need to do any other stuff in there. So it really depends on who you are. If you're the CEO, you really need the original file, but then you're also a very good target. So the first pipeline we want to talk about is the real-time pipeline. The real-time pipeline is all about taking a document, first checking against the signature. You never know. The majority of the files are actually known within the signature database. Check against the signatures. You would get a result back a few seconds, probably recommended to use multiple signature engines. And then once you know that if the file is bad, you obviously block it. If the file is valid, the next thing would be sending it into our through type detection. So we'll apply file type detection. We'll understand if this is really a document or not. If it's an executable, it goes into another bracket lecture. If it's a document that we'd like to get in for a real-time pipeline with the best security is we would render the document remotely. That's why we call an isolated document. By the way, just to explain, when you actually open a PDF document in your Gmail account, that doesn't render remotely necessarily. Chrome has Chromium has what's being called PDFium, which is a component that actually runs inside your endpoint. So we're talking about really rendering these guys remotely. The next type of pipeline would be a near real-time pipeline, where after we send the document to signatures and file type detection, we'll isolate the document, but then whenever the user hits the download button, right, this is where we can kick in with static analysis and CDR. This is like us saying, oh, do you really need the file? If you really need the file, right, we're not sure. It's pretty dangerous. Let's run some other quick analysis. CDR would reconstruct the file, so you would get a new version of the file. There's also what we call an async pipeline or an offline pipeline. I like the async actually better. What it means is that once we verified that nobody knows what this is, so we pass signature check. Once we verified it's a true type as we suspected, we can actually, instead of sending it, the obvious way would be to send it to the sandbox, but then again recall how error-prone sandboxes can be. Lots of Black Hat talks in the past talked about that. So what we can do is we can actually send the file to a remote viewer, but in the background send it to a sandbox. Right? Then at least we give the user the ability to detect, to analyze, to understand if he needs the file or not. And that's another psychological jump where we actually educate the users if you really need the file. Just be aware, not every file is downloadable or needs to be downloaded. But once the user clicks the download button, it's good chances that the sandbox has already finished processing, so we have better visibility on what went wrong, and we were able to actually eliminate some of the fundamental sandbox issues. We then can obviously apply static code analysis and CDR, right? So that's a good example. If you consider the email, if you consider the email track would be if I get an email and I have control on that email before it reaches the endpoint mailbox or the next hop mailbox, so if I have some sort of an MTA or an API into the mailbox, what I can do is I can apply signatures, file type, and then replace the item with a link, right? And then it will be redirected into some sandbox or isolation or static code analysis. So the idea is to understand what's the difference between these guys, and then when it's appropriate on a policy-based approach. Another good example for a policy would be when we looked at the risk levels, right? So again, majority of the web today is uncategorized, right? Uncategorized and probably unknown. So what we'll do is, if this is known, we can basically just apply signatures and file types, right? But if it's unknown, we want to put in the full-blown pipeline. So in terms of, just to sum it up, each one of those components could be from a different vendor, right? Some of these are actually open source. TrideNet is a pretty cheap component, very valuable for tool-type detection. And what makes a lot of sense is to own at least some of the components in the box and analyze if they make sense or not, and then look at the orchestration workflow that you need on a policy-based approach. So really try to differentiate between real-time and offline analysis. And then what I found to be also very interesting is you need to apply this to the users in the organization. So understand what are the pain points, right? And then be able to attach the right workflow. From a red team point of view, each one of those components had at least the vulnerabilities, or at least the disadvantages that we discussed. So really understand what are the disadvantages, right? And how to actually construct the pipeline the right way. So that's it, guys. We're almost running out of time, so thank you very much. We'll stay here to take any questions if you might have, and enjoy the rest of the Black Hat.